December of 1986. 11 horses stepped down from a cargo plane onto a stretch of desert, so lifeless that local ranchers had given up calling it land altogether. They called it the place where nothing grows. No grass, no water, winters that plunged 40 degrees below zero. China had just spent millions flying these zoo-raised animals halfway across the world to release them here. And virtually every serious ecologist on Earth was calling it a death sentence. A BBC crew arrived to film the release. They packed their gear and flew out after just 2 days, convinced they were witnessing a disaster as it unfolded. What those 11 horses did next was something nobody thought was even remotely possible. This project is one piece of a quarter-century-long effort that started when 4 wild horses were brought into captivity for the sole purpose of one day being returned to the wild. 11 horses pitted against a dead desert. Because these are no ordinary horses. They are Przewalski's horses, the last genuinely wild horse species remaining on the planet. Absent from this region for 17 years. The Chinese government had just spent millions of dollars transporting them halfway around the globe from zoos in East Germany and the United States, releasing them into a desert that was consuming 3,000 square kilometers of new ground every single year. Leading ecologists were already labeling the project a death sentence before it even began. These were animals that had lived their entire lives eating hay out of buckets and drinking water from automated dispensers. Now they were being dropped into a place where winter temperatures collapsed to negative 40 degrees Fahrenheit and summer heat climbed to 104. The nearest water source could sit 15 kilometers away, sealed beneath 4 inches of solid ice. The horses themselves looked almost otherworldly, compact and stocky in build, with stiff mohawk manes rising straight up like something out of a child's drawing. Faint, zebra-like stripes traced down their legs. They resembled less a modern animal and more the figures our ancestors carved into cave walls 40,000 years ago. These were Przewalski's horses, the only remaining truly wild horse species on Earth. Survival experts working in desert environments gave them perhaps a 15% chance of making it through the first winter. One ecologist, writing in Nature magazine, described the entire project as throwing good money after dead soil. Local officials in Jimsar County were already preparing public statements to account for the inevitable failure. And to understand why anyone would attempt something this reckless, you first have to understand what the Yungar Basin had actually turned into by 1986. Because this was not just another conservation effort. This was about preventing an entire region of China from becoming wholly uninhabitable, a wasteland that was actively devouring the country from within. The Yungar Basin had not always been a wasteland. For 10,000 years, wild horses had moved freely across these steppes. The entire ecosystem had shaped itself around the rhythm of their hooves. Then, in 1969, they disappeared. Not gradually, completely. The last confirmed sighting was recorded by a Soviet geological survey team. A few hoof impressions pressed into drying mud, a small cluster of tan hairs snagged on desert grass. After that, nothing but silence. And here is the part that no one anticipated. What came next was an ecological collapse of a magnitude that left even the most pessimistic scientists stunned. Without horses working the surface, the soil hardened into what researchers began calling biological concrete. Rain still fell across the region, 4 to 6 inches each year. But rather than soaking into the earth, the water ran off the impermeable crust in sheets and evaporated within hours. Seeds were unable to break through the hardened surface to germinate. Nitrogen levels fell so sharply that by 1974, scientists were comparing soil samples taken from the basin to lunar dust. The material was technically still present. The grains of sand and silt looked unchanged under a microscope. The basin had simply gone biologically dead, and then the desert began to move. Satellite images captured in 1982 showed the Gobi advancing at 70 kilometers per decade, swallowing grasslands, villages, and farmland without pause. Highways had to be rerouted. Railway lines were being buried beneath the sand. Beijing, sitting more than 1,000 miles away, was getting battered by dust storms that dragged on for days at a stretch. And here is the thing. Back in March of 1983, a single storm buried the Chinese capital under 43,000 tons of topsoil stripped from the Yangtze Basin in under 72 hours. Hospitals recorded a 300% surge in respiratory emergencies. People were suffocating on a desert they would never lay eyes on, inhaling soil blown in from a place 1,000 miles distant. So China tried everything it could think of. The Green Great Wall Project, set in motion in 1978, set out to plant a forested barrier stretching 4,500 kilometers across the northern edge of the country. But here is where it fell apart. Those trees demanded more water than the desert could possibly supply. Water tables that had held steady for centuries dropped by 12 meters in certain areas. The trees themselves, lined up in tidy rows like a marching formation, began dying from the roots upward as the falling water table slipped beyond their reach. Entire villages had to be abandoned when their wells went completely dry. Engineers experimented with straw grids to pin down the sand. They tried planting shrubs bred for drought conditions. Nothing managed to hold the line. By 1985, this had become a full-on crisis. Agricultural output across Xinjiang province had collapsed by 34%. Year after year, the desert crept closer to Beijing. Computer projections suggested that, at the rate things were going, the Chinese capital itself would be barely livable by 2150. And that is exactly the catastrophe a small team of Chinese ecologists, led by a researcher named Yang Jianming, was staring down when they walked into a government meeting in 1985 and put forward something that sounded completely far-fetched. Yang stood before officials who had spent 2 decades watching tree after tree wither and die, watching wells go dry, watching dust consume their capital. And he told them to stop. Stop throwing bulldozers and tree plantations at the desert. Bring back the creature that had kept this land functioning since the last ice age. Bring back the wild horse. By every account, the room was not exactly thrilled by this suggestion, but the numbers were so grim, the failures so absolute, that within a matter of months, his proposal was approved, which left exactly one question hanging unanswered. How could animals raised in zoos, hand-fed by people across 3 generations, possibly survive a landscape that was swallowing entire cities? The last truly wild horse. The Przewalski's horse is not just any ordinary horse. Take a look at its DNA and you will find 66 chromosomes rather than the 64 found in every domestic horse. It is the only horse species on the planet that has never been domesticated, never broken in, never tamed. While humans were selectively breeding Arabians for speed and Clydesdales for raw strength, Przewalski's horses remained exactly as they had always been, unchanged since our ancestors were sketching them onto cave walls in the distant past. They are a living portal into the Ice Age. The Przewalski's horse is genetically distinct and stands as the only true wild horse subspecies still in existence. But here's where it gets really striking. By 1985, that portal was nearly shut. Only around 900 of these animals existed anywhere on Earth, and every last one of them lived inside a zoo. The entire species could be traced back to just 12 to 14 individuals captured between 1899 and 1903 by Russian explorers working on contract for European zoo collectors. Following World War II, the worldwide population hit an absolute low of 31 horses, with only 9 capable of breeding. At one truly terrifying moment, the species clung to survival in just 2 places on the entire planet, the Munich Zoo and the Prague Zoo. Every Przewalski's horse alive today carries that genetic bottleneck locked inside its cells, a chromosomal scar left behind from coming within a hair's breadth of total extinction. The simple fact that any remained to be sent to China in 1986 was, by itself, something close to a miracle. China's plan, drawn up in 1985 and set in motion in 1986, was structured around 3 phases. First, bring horses in from Western zoos and acclimatize them at a newly constructed breeding center established in Jimsar. Second, move them into large, semi-wild enclosures, essentially retraining zoo-bred animals in how to be wild once more. The third phase involved releasing the horses into the Kameli Nature Reserve, 4,000 kilometers of some of the most unforgiving terrain found anywhere in Asia. Among the earliest horses transferred into the Jimsar enclosures was a young stallion with a clean white blaze running straight down his face. The keepers gave him the name Hong. Hold on to that name. You will need it later. Now here is where things start to get genuinely fascinating. Yang's case to the government was not simply that these horses would make it out there. His argument was that they would actively reconstruct the ecosystem around them. These animals do not merely graze on grass. He told them they reshape entire landscapes. And once you understand how, the whole story stops feeling far-fetched. It comes down to three things. The first is raw physical force. Each horse carries between 600 and 800 pounds of body weight. When they run, their hooves strike the earth with 800 pounds of pressure per square inch, more than what a jackhammer delivers. In a place like the Younger Basin, where the soil had essentially become biological concrete, that is precisely the kind of impact needed to crack the hardened crust open and allow water to seep back in. But here is what machines are simply not capable of doing. Horses are selective about where they tread. They navigate around delicate young plants and only pound down on bare soil and dead vegetation. They can tell the difference. Then there is the matter of how they move. GPS tracking later showed that Przewalski's horses cover roughly 15 kilometers each day in what mathematicians describe as fractal patterns. They graze intensively in a single area for hours, then abruptly move several miles away, then loop back around. It looks completely random. It is anything but. This movement creates what is called a disturbance mosaic. Short grass in one spot, tall grass in another, bare patches scattered throughout. Each of these tiny microhabitats ends up supporting entirely different species of insects, birds, and small mammals. The horses are not simply feeding themselves, they are engineering a living patchwork. And now the third thing, which is arguably the part that sounds the most outrageous. Horse manure is not waste. It turns out to be a delivery system. Analysis of Przewalski's horse dung found viable seeds from more than 20 distinct plant species inside. The journey those seeds take through a horse's digestive tract actually boosts germination rates by as much as 300%. The acids in their gut scarify tough seed coatings and break dormancy in seeds that might otherwise have stayed locked up for years. A single gram of dung holds up to 7.4 viable seedlings, double the dispersal rate of cattle and 8 times that of sheep. And since these horses are traveling 15 kilometers every single day, they are continuously seeding enormous stretches of land, forging genetic corridors between plant populations that had been cut off from one another for decades. Every pile of dung is, in a very real sense, a self-watering, pre-fertilized seed packet. That was Yang's pitch. That was the theory. The problem was that the horses about to be set loose had spent 3 to 4 generations living behind fences. There are currently 900 Przewalski's horses in China, a genuinely remarkable achievement for wildlife conservation. But they no longer knew how to locate water in a desert. They did not register the sound of a wolf as something threatening. They had never experienced temperatures that dropped below freezing or climbed above 90 degrees. They had lost what researchers referred to as the culture of survival, the learned behaviors passed down from mother to foal that no amount of genetic programming alone can ever replace. So the question that would determine whether Yang was a visionary or simply fooling himself was a straightforward one. Had 3 generations of zoo life smothered the instincts buried deep within these animals, or were those instincts still somewhere inside them, waiting to surface? Before we get to that, before I tell you what actually happened the moment these horses set foot in that desert, do me a quick favor. If this story is holding your attention, go ahead and hit subscribe and tap the bell. Every single week, we dig into stories exactly like this one, the kind that quietly rewrite everything we thought we understood about how the natural world operates. And what happens in the next part of this story is something almost no one believed was even possible. Those zoo-raised animals and what they did through their first winter What a single stallion pulled off on day 8 after release, and the figure researchers eventually landed on for what just one of these horses is worth to the ecosystem. Stay with me, the reward is worth it. A winter that should have finished them off. Those opening months at Gemsar were a battle that almost proved every critic correct. Within just a few weeks, botfly infestations had swept through the entire herd. 100% infection. And these were no ordinary parasites. The larvae burrowed deep into the horses' stomachs, carving out painful lesions that destroyed their digestion at exactly the moment their bodies needed every single calorie just to stay alive. Then the first winter arrived, and it was nothing short of catastrophic. Temperatures plunged to negative 42 degrees Fahrenheit. These horses, raised in heated barns their whole lives, pressed together against frozen winds that tore across the desert like razor blades. Their signature mohawk manes turned to icy ridges so thick and heavy that some animals could barely lift their heads from the ground. Snow smothered what little grass existed beneath 3 feet of powder, and here is where things turned genuinely brutal. The staff at Gemsar, Yong's team, watched through binoculars and had strict instructions not to step in unless the entire herd faced total collapse. 7 horses developed serious frostbite. 2 mares lost their foals to the cold. The international press was already composing the project's obituary. Conservation journals were drafting post-mortems for what they assumed would be a textbook cautionary tale. Yong himself, by his own later admission, was quietly bracing for the worst. But something else was unfolding out on that frozen steppe, something no one had written into the plan. The stallions began breaking through the ice with their hooves to reach the water underneath, a behavior never once recorded in any zoo anywhere in the world. The mares started forming protective circles around their foals during storms, using their own bodies as windbreaks and rotating positions whenever one mare grew too cold. The horses taught themselves to sweep through the snow with a rocking motion of their front legs, uncovering grass that no domestic horse would ever have thought to search for. They began reading the wind, figuring out which slopes had been scoured clean by the cold and which ones had swallowed deep drifts of snow. And that barely covers it. They were not simply surviving. They were remembering. Generations spent in zoos had not wiped out what had been inscribed in their very bones. The instincts had been there all along, dormant, waiting. The desert was calling them back. By spring of 1987, the transformation had surged beyond anything the project's models had anticipated. Grass species that hadn't appeared in the basin for 17 years began pushing up through the soil wherever the horses had grazed. Compensatory growth, the process by which grasses regenerate faster and denser after being cropped, boosted biomass by 43% in grazed areas when measured against ungrazed controls. The horses weren't tearing the land apart. They were activating it. The soil itself began shifting in ways that left the monitoring scientists speechless. In that first year alone, moisture retention climbed by 23%, not because more rain had fallen, not because the climate had changed in any way, but because the horses' hooves had punched roughly 10,000 tiny craters into every single hectare of ground. Each one of those small depressions became a miniature reservoir, catching precious rainwater that would otherwise have sheeted off the hardpan and vanished through evaporation within hours. The horses were rebuilding the basin's entire water system, one hoofprint at a time. The second year brought another revelation. Nitrogen levels spiked by 37%. The horse manure wasn't just feeding the soil. It was reintroducing the gut bacteria the earth had been missing for decades, an entire microbial community that had disappeared the very moment the wild horses did. By the third year, botanists were recording something that should have been flat out impossible. 22 plant species had reappeared, seemingly out of nowhere. Their seeds had apparently been lying dormant beneath the soil for nearly 2 decades, waiting patiently for the right conditions to finally sprout. The basin had never truly been dead. It had simply been sleeping, waiting for the one species that knew how to bring it back to life. But here's the thing: surviving one winter does not mean a population is restored. The horses still had to do it all over again and again, and when that second winter arrived, it would determine whether that first remarkable season was the start of something genuine or just a lucky one-off. The ecosystem stirs back to life. It was not a one-off. The horses came through the second winter, then the third, and then the fourth. And once the plants returned, everything else came along with them. Dung beetles, absent from the basin for 15 years, came back by the millions. They buried horse manure deep into the ground, enriching the soil even further and speeding up the recovery cycle. Field surveys began recording 43 insect species that had not been seen in the region for decades. The insects drew in the birds. Larks, wheatears, and sand grouse arrived to feed. Small mammals followed the birds. Gerbils, pikas, ground squirrels, and then the predators reappeared. Foxes, steppe eagles, and even the occasional gray wolf began showing up on the camera traps. Every new species added another layer of complexity, another feedback loop pushing the recovery further along. By the late 1990s, the herd at Jimsar had grown large enough and the basin had recovered enough that Yang's team made a decision that would have seemed completely absurd a decade earlier. They were going to take the fences down. In August of 2001, the project moved into its most daring phase. 27 horses were chosen for a full release into the Colomile Nature Reserve. No fences, no supplemental feeding, no human involvement of any kind. Just horses and 4,000 square kilometers of desert that had not seen their kind in 32 years. Among those 27 was Hong, the stallion with the white blaze on his face, now fully grown and leading a harem of his own. The scientists fitted the horses with GPS collars, positioned camera traps throughout the area, and waited anxiously. During the first week, the horses stayed within 500 meters of the release point, almost as though held in place by invisible chains. They wandered in circles. They grazed with visible unease. They kept glancing back in the direction of the pens. And then came day 8. Day 8. It was just after dawn. According to the field notes, the wind was blowing steadily out of the northwest. The GPS team at the monitoring station was watching the screen, more out of routine than expectation, when one of the dots on the map began to move. Then the dots surrounding it started moving too. Hong was on his feet, and his harem was falling into line behind him. He did not wander. He did not stop to graze. He walked north in a straight line, as though he knew precisely where he was headed. The dots kept moving, 5 kilometers, 10, 15. The monitoring teams started calling each other. By the time Hong finally stopped, he had led his harem 30 kilometers north to a water source that appeared on none of the project's maps. Nobody had pointed him in that direction. No previous generation of his bloodline had traveled that route within his lifetime. He simply knew. The team drove out the following morning to verify what the GPS data had already shown them. And there it was, a spring-fed pool, half frozen over, sitting tucked against a low ridge. Hong was standing beside it as casually as if he had been coming there his entire life. How he found it remains one of the great unanswered mysteries of the whole operation. Some form of ancestral memory, perhaps, a scent carried on the wind, some pattern written into the geology that horses can interpret and we simply cannot. Within a month, the horses had established their territories. Stallions were marking boundaries with dung piles placed deliberately on elevated ground. Natural foaling rates reached 87%, far higher than what most zoo populations are able to achieve. And the foals being born out there in the wild were displaying behaviors that captive-born horses simply never show. They could identify 23 different plant species by scent alone. They responded to the shadow of a golden eagle passing overhead by freezing completely still. Their winter coats grew thicker than those of their parents, and the transformation across the landscape had become visible even from orbit. Satellite images captured green patches spreading outward from the horse's core territories like explosions playing out in slow motion. The water table, which had been declining by 3 centimeters every year since 1970, stabilized in 2003, and then it began climbing again. The horses had reactivated a hydrological pump that had been sitting dormant for an entire generation, a single number that broke every model they had. What was unfolding in the Yungar Basin demolished everything China believed it understood about combating deserts. For 25 years, the Green Great Wall had rested on a single assumption: plant trees to hold back the sand. By 2010, China had put 66 billion trees in the ground at a cost of $47 billion. And across many regions, those trees had made the underlying crisis dramatically worse, drawing water out of the soil faster than the land was able to replenish it. And here is the part that should have rewritten the entire playbook. While China's enormous tree planting program was essentially drinking the desert dry, the horses were doing something entirely different. They were pulling the water back. Their hooves punched infiltration points into the ground, allowing rare rainfall to sink deep into the soil rather than evaporating straight off the hardened surface. Their grazing was sustaining grasslands, which need 90% less water than forests do. One single horse was improving water retention across 50 hectares every year. Then someone ran the numbers, and those numbers stopped sounding like ecology and started sounding like a financial report. When ecological economists sat down to work out what a single Przewalski's horse was genuinely worth to the ecosystem around it, they came back with figures nobody had anticipated. Soil restoration valued at $12,000 per horse per year. Seed dispersal, $8,000. Water retention, $15,000. Carbon sequestration, $7,000, biodiversity support, $5,000, a total of $47,000 per horse per year. When they calculated the cumulative figure, the economists became the next group, after the BBC crew and the conservation journals, to stare at their own results twice before accepting them. Because by 2023, those 11 horses had grown into 534, and the herd was effectively managing 26,700 hectares of land, a territory larger than many national parks, generating $25 million in ecological value every single year. And that was a conservative estimate, not counting tourism, scientific research, or what the basin had become worth in carbon credits. Among those 534 horses were many of Hong's descendants, dozens of them, spread across the reserve in harems of their own. The lifeless soil they had been released onto now supported more than 20 plant species that had not been seen there in decades. And the desert that had been swallowing thousands of square kilometers every year was now retreating, pulling back at a rate of 47 hectares annually across the zones where these horses moved freely. The model traveled quickly. Mongolia released horses into Hustai National Park in 1992, and by 2023, the population there had reached 490 individuals, with the surrounding steppe showing the exact same restoration patterns as Xinjiang. Kazakhstan launched its Golden Steppe project in 2024, transporting horses from Prague and Berlin into the Kostanay region. 8 years on, there were more than 100. Now nearly 1,000 have been set loose to range across Central Asia. Russia has been quietly reviewing the Chinese data. Every project kept confirming the same core principle. You cannot engineer an ecosystem from the top down using human blueprints and reinforced concrete. You have to rebuild it from the bottom up using evolutionary solutions that have already been road-tested across thousands of years. China is now extending the Kalamili Reserve by another 350 square kilometers. The official target is 2,500 wild horses by 2040. Computational models indicate that a population of that scale could restore over 100,000 hectares of damaged land, sequester 43,000 tons of carbon annually, and sustain more than 300 plant and animal species that currently have no other home anywhere in China. Should they succeed, the Yungar Basin will stand as the first desert in recorded human history to be turned around, not through planting, not through irrigation, not through engineering, but through the hooves of wild horses. Those 11 animals that walked off that cargo plane back in 1986 were never simply a handful of endangered creatures being moved to a new location. They were a biological technology shaped by evolution across hundreds of thousands of years, fully capable of designing and sustaining an entire landscape on their own. We only needed to remember where the switch was. We just had to step aside and hand things over to the real specialists, the ones with hooves. The Przewalski's horses push us toward an uncomfortable question. How many of the ecological disasters we are dealing with right now could actually be fixed by returning the original engineers we pushed into extinction, rather than pouring trillions of dollars into human-designed solutions that keep failing? The bison that built the American prairie, the wolves that kept the forests of Europe in balance, the elephants that tend the savannas of Africa. For the entire modern era, humanity has been trying to manage and engineer nature, but nature had already worked out the answer long ago. We simply destroyed it and then lost the instructions. Drop your thoughts down in the comments. If you could bring back one extinct ecosystem engineer anywhere on the planet to help repair land we have wrecked, which species would it be, and what is your reason? I read through every single comment. And if you are after more stories about animals that have genuinely reshaped whole continents, your next move is hitting that subscribe button. The story we are putting together next might just be the most extraordinary one yet.